Okay, let's solve quiz 3. We're looking at the nickel aluminum phase diagram. The first question asks us to consider a system with 30 atomic percent nickel at 700 degrees Celsius. Here's the phase diagram. On the top, we have weight percent. On the bottom, we have atomic percent. 30% there, and 800. Well, let's draw a line up first. 30% up, and 700 degrees Celsius. Which is right here. Identifying the phases. We know, reading a phase diagram, that on the far left and on the far right, we have single phase regions. So this is a single phase aluminum. This is single phase nickel. So if you have a single phase region, then the next region has to be a two phase region, because you can't have two single phase regions in contact with each other. So that must be a two phase region, which then we have a single phase region, and that is going to be a line compound. So that is single, which means this is a two phase region, which means this is a single phase region, and this is a solid solution. So we know that our two phase region of the phase diagram is bracketed by Al3Ni, a line compound, and Al3Ni2. So that's the region we're in. So now we can use our tie line to identify the composition of each of these phases. So Al3Ni, well, that's a line compound. It's 3 parts aluminum to 1 part nickel, so it is 25% nickel. And in fact, if we draw a vertical line down from this intercept, we see that it reads 25 atomic percent. Great. So X and I of Al3 and I is equal to 25 atomic percent. I had questions during the quiz about if I wanted atomic percent or weight percent. They're both okay, but the important thing is that when you report your units, you should report which one they are. And sometimes that's kind of implicit, depending on the context of people, for example, working in the steel industry in manufacture. You know, it's just commonplace to use weight percent to talk about carbon contribution to iron. People working in, say, molecular work, for example, my research, we just do everything in atomic percent. But really, to be thorough, you should actually have whether you have weight percent or atomic percent. Okay, let's go to the next phase right here. So this should be 3 parts aluminum to 1 part nickel if we have the stoichiometric compound, but it's not stoichiometric. It is a solid solution that occupies this range. So we can draw a vertical line, which looks a lot like the vertical line that's already drawn there. And that reads 37%. So X and I in Al3 Ni2 is equal to 37 atomic percent. Okay, so we've identified the two phases. We've identified the composition. Let's do the phase fraction. Let's take the fraction of Al3 Ni. So Al3Ni is on this side. So if we had that whole inverse lever rule business, then we are going to be reading that divided by the total length across. So that's going to give us the fraction of Al3Ni is equal to 37 minus 30, because 30 atomic percent was our system composition, divided by 37 minus 25, which is 7 divided by 12. And then the fraction of Al3Ni2 is 1 minus 7/12. And you can put that in a calculator and get an answer, but this is how you set up the problem. Okay, next problem. The next part is same phase system. Now it is 70 weight% nickel at 1200 C. And then phases, present phase, fraction, etc. So this one, I went from atomic percent to weight%. I know that many people didn't do that, so we gave partial credit, heavily gave partial credit for this. So we just took off a few points for getting those two confused. So let's go here to 70 weight%. 60, 70, and 1200 Celsius. Okay, so got a single phase region, which means a two-phase region, which means a single phase region, two-phase region, single, two, single, two, single. Single phase region. Single phase region is right at 50%. It corresponds to AlNi. We've got a solid solution, a fairly broad solid solution, and our system is at this point. So we say, what fraction of our system is AlNi? And it is 100%. Great. And we say, okay, what composition is our system? Well, it's 70 weight%. If you really feel the need, you can come down here and it's like 51 atomic percent. But you don't really need that. So we say fraction of AlNi equals 1. Xni in AlNi is equal to 70 weight% or 52 atomic percent. And that's part 2. Part 3. What is the maximum atomic percent of aluminum in nickel at 800 C? So this is our pure nickel, and we said 800, so that's going to be here. And you remember that we can think about these phase boundaries as solubility limits, right? We start out with pure nickel. We start putting in aluminum. The aluminum is sitting at the nickel site, and it looks like nickel, except that, maybe there's some slight distortion to the X-ray diffraction pattern. Maybe the lattice parameters change a little bit, but it basically behaves like this nickel gamma phase. And we come over to this point, and at this point, we reach the solubility limit. We add more aluminum, and now we have two phases. We have the nickel gamma phase, and then we have a gamma prime phase. And that gamma prime phase is AlNi3. So that's where we have the solubility limit, where we start precipitating out an aluminum-rich phase and a nickel-rich phase. So that solubility limit is right there, which looks like about 88. So that's 88% nickel. And the question was about aluminum, and that means that we can have 12% 12 atomic percent aluminum, and that's the limit. when we put in 13 atomic percent aluminum, we've shifted one to the left here, and we start precipitating out. So 12 atomic percent aluminum. Okay, next, on the phase diagram, draw a square around congruent melting points. Okay, congruent melting points. The simplest and the most obvious one is right here. And on the phase diagram, draw a triangle around any paratectic point. And I should be specified, I only need one for each of these for full credit. I wasn't expecting you to identify all of them. So let's just draw one, or we'll draw several, right? That's a paratectic point. Triangle, okay? There's one. We had one here. Remember from the video, I zoomed in. So those are our paratectic points, the places where we have, as we cool down, we're forming Al3Ni2, and as we cool down into the next region lower, the Al3Ni2 completely dissolves and precipitates out Al3Ni. And then the last question is draw a star around eutectic points. So we've got one here. We've got one here. And again, that was something that I talked about in the video. And those are the two that I see, obviously. I want to point out here also that there are paratectoids, which are different from paratectics, because a paratectoid is a solid forming a two-phase solid region forming a single-phase solid region, and that's right here. And we're not looking for those. We were looking for the paratectic, which involves a liquid solid forming a solid. So these are the solutions to Quiz 3 Spring 2019.